So today I want to talk about this paper called CAMEL. When I first saw the title, I was like, what? CAMEL? But it is actually about two AIs talk each other and work together without any human guidance. And what kind of wild is the whole thing runs on a few prompts. So let's get into it. The paper starts with a problem I think a lot of people have felt. Say you want to build a trading board with AI. To actually get something useful, you already need to know which libraries to use, how to break the problem down, what to ask. And if you don't, the AI just gives you something vague. So people who need the AI the most are often the ones who struggle to use it. That's the gap this paper is trying to close. Their answer is pretty simple. Replace the human in the middle with another AI. One AI acts as the manager and gives instructions. That's the AI user. Another AI executes. That's the AI assistant. You give one initial idea and the two agents work it out from there. And what I find interesting is they're not building a new model. They're using GPT 3.5 and just changing how the two instances interact with each other. Here's how it works. A human idea goes to the task specifier, which turns something vague into something concrete. Build a training board becomes build a board that monitors social media sentiment and auto-trade based on that. Then the AI user and AI assistant take over, going back and forth until the task is done. There's also critic in the loop. You can insert a human or another AI to review decisions along the way, kind of like a quality check. What makes this run is something they call Inception Prompting, named after the movie. The idea is you only do your prompting engineering once, at the very beginning, with 3 prompts. The task specifier prompt, the assistant system prompt, and the user system prompt. Once those are set, the agents start prompting each other automatically. You don't touch it after that. These prompts aren't just setting roles. They define how the agent communicate, what format responses need to be in, and when everything stops. Okay, this is honestly my favorite part. They ran the experiment, let the two agents talk, and things broke almost immediately. First, role flipping. The AI assistant, whose job is to follow instructions, just started giving orders instead. The fix? 2 sentences added to the prompt. Never flip roles. Never instruct me. Done. Second, the parrot effect. You ask the AI to write code, and it goes, I will write the code, and then does nothing. They fixed it by requiring every responses to start with solution, followed by an actual answer. Third, flake replies. The AI will say, I will do something without any actual implementation. They fixed this by requiring responses to always end with the next request, forces the assistant to actually complete what it was asked. And fourth, the infinite loop. Task is done and the two AIs just keep thanking each other. The paper literally describes them falling into a chatting loop where they keep saying thank you or goodbye indefinitely. The fix was a termination token, CAMEL task done. AI user sends that, conversation stops. So why does this matter? A few things. The paper showed that solutions from this framework actually outperformed single-shot GPT 3.5 responses in both GPT-4 and human evaluations. They generated 25,000 conversations just from the AI society dataset. And if you look at where multi-agent AI went after this, Kura AI, AutoGen, LangGraph, they're all built around the same core idea. Assign roles, set up a communication framework, let them run. CAMEL was one of the first papers to show this could work, and to document exactly what breaks when it doesn't. And yeah, that's CAMEL. No new model, no new architecture.
Just a framework, some carefully designed prompts, and 2 instances of GPT 3.5 talking to each other. And somehow that one paper ended up shaping all of multi-agent AI today.